Hello, this is a video made by special request. So we have a young student working on some calculus problems and wanted to know about how to work out the antiderivative of the reciprocal of the square of x squared minus 6x plus 11, which is a very challenging problem. Uh, not because any particular step is so very hard, but just because there are so many steps involved in getting to a final solution. So let's jump into it. So a good approach here when we have 1 over something squared, a polynomial like this, a quadratic, is to complete the square. And so we'll do that over on the side here. So we have x squared minus 6x plus 11. And I can break that up as x minus 3 squared. And if I stopped right here, then the constant term would be 9. But I need 11, so I have to add 2 more to get to 11. All right, so that gets us to a slightly different problem. So I'll have x minus 3 quantity squared plus 2, and then I square it. And in my mind, first thing I want to do is just ignore this square for a moment. So in my mind, I'm thinking about this antiderivative, which I know is going to be the arctan of x. Okay, a lot of teachers will tell you got to put plus c, but I always take this to mean an antiderivative, so I'm not going to be writing my plus c's in this video. But you probably should for your teacher because, well, they think it's the right thing to do. Anyhow, so let's see here. It's not quite going to be like this because there's a square, but you know what? This is the right intuition. This actually, right, is how I'm going to want to think about the answer. Like, I think it should be something like an arctan, and this tells me that I actually want to do a tangent substitution. Now, if this is just x squared, then I would make x equal to tangent. But okay, a little shift, right, by a constant, that doesn't bother me too much. So I do, instead of x equaling tangent of something, I'm just going to let x minus 3 equaling a tangent. So I'd like to do it exactly like this. Only if I do that, then when I square everything, I'm going to get tangent squared plus 2. And well, once again, in the back of my mind, I have an idea, which is I know that tangent squared plus 1 is equal to secant squared. So this is as a plus 2. So the way I'm going to handle that is by putting a square root of 2 there. So when I square x minus 3, then here I would get 2 tangent squared plus 2. Well, 2 tangent squared plus 2, that's just twice what I have above. That would be twice secant squared. Okay, so that's where the inspiration for this root 2 is coming from. All right. Now, of course, I'm going to have to change this dx, so I might as well compute that now. Derivative of x minus 3 is just 1, so dx is equal to the square root of 2 times the derivative of tangent, which is secant squared, and then I get du. Okay, so let's jump in here now. I have 1 over, okay, x minus 3 is this root 2 tangent. Square it, I get 2 tangent squared. So I have 2 tangent squared u plus 2. Of course, there's still this square. And then dx can turn into the square root of 2 secant squared u du. All right, now I have this little identity over here. And then, of course, if I square everything, I'll get 4 secant to the 4th. So this piece right here is going to be 4 secant to the 4th u. This is not too shabby because first, okay, this root 2 and this 4 in the bottom, they're just constants. So let me pull those out. Root 2 over 4. Okay, what's left over? I have a secant squared divided by a secant to the 4th. Okay, let's just do a little work on the side. Secant squared divided by secant to the 4th. Okay, I can cancel 2 of the secants, and I just get a secant squared on the bottom. But the reciprocal of secant is cosine. So the reciprocal of secant squared is cosine squared. So I actually just get cosine squared u du. All right, and at this point, this is probably an antiderivative that you've seen before. There's a lot of ways of attacking this one. You could do a trig identity, right? You may like using a double angle. I happen to enjoy using the integration by parts to get this. I'm going to assume you know how to do this though, and so if you don't, you let me know, and I'll direct you to. I think I have videos on this, in fact. So this is going to be 1/2 u plus sine of u cosine of u. Okay, so I now have root 2 over 4. But there's now going to be a half, so actually I can make this over 8. So there's a root 2 over 8, and I have u plus sine of u cosine of u. Okay, are we done? All right, the integral's gone. Well, not quite, because we still have the answer in terms of u, and the original question is in terms of x. So let's try to turn this back. Well, what do we have? Oh my goodness, we have to solve this for u. So if I want to solve this for u, well, I could divide by the square root of 2, and then I'll have tangent of u. Okay, I better take the arctan. So if I take the arctan, then I'll just get u out. Okay, so I can now jump down here, and everywhere I see a u, I can replace it with this arctan. So I have the square root of 2 over 8 times the arctan of x minus 3 over the square root of 2, okay, plus the sine of, oh my goodness, the sine of the arctan of x minus 3 over the square root of 2 times the cosine of the arctan x minus 3 over the square root of 2. Woo! Close that off, close off the big parenthesis. Okay, we got it. Okay, now it's all written in terms of x. So in principle, we're done. In practice, these expressions where you have the sine of an arc function, we typically like to simplify those. Okay, and the way I like to do it is using a right triangle. So I'm going to draw a little right triangle over here. And I'm going to pick some angle. This is my right angle over there. So I know that when I take the sine of an angle, I get a number. When I take the arc sine of a number, I get an angle. Same with tangent. If I take the arc tangent of a number, I get an angle. Okay, well that's what this angle is going to be. So this angle over here is the arctan x minus 3 over the square root of 2. Now, how do you compute the tangent of an angle? Well, to get the tangent of an angle, you look at the opposite over the adjacent if you're working in a right triangle. And I know what I would get if I took the tangent of this angle, right? If I took the tangent of the arctan of x minus 3 over the square root of 2 inside this right triangle, I'm just going to get x minus 3 over the square root of 2. Okay, but again, to get the tangent, I look at the opposite over the adjacent. Well, look, this looks just like an opposite over an adjacent. X minus 3 could be the opposite. Root 2 could be the adjacent. Now I can use the Pythagorean theorem to get the hypotenuse of this right triangle. So let's see. I would get the square root of x minus 3 squared plus the square root of 2 squared, which is just 2. And this is really cool because this expression down here, this x minus 3 squared plus 2, that's exactly what we got when we did the completion of the square of our original denominator. All right, so that's kind of neat. Okay, well now we can actually go back here and say, well, what is the sine of this angle, the arctan? And I get the sine by taking the opposite over the hypotenuse. All right, so that means that this piece here, the opposite is x minus 3, and the hypotenuse is this root x minus 3 squared plus 2. What about this cosine? All right, well, we don't need these little squiggles anymore. This cosine, well, I get the cosine by taking the adjacent over the hypotenuse. So I take the root 2 over, again, the hypotenuse is the square root, the square of x minus 3 plus 2. Okay, I can put this all now together, and we get our final answer. Let's see, what would I like to do? Well, I notice, yeah, these in the bottom, they're going to combine. That's really nice. Ooh, look at this. There's a root 2 here that's going to get multiplied by x minus 3, and there's a root 2 outside. If I put that inside, then I'm going to get a 2. That feels pretty good. So let me leave the 1/8 outside. And then, okay, the root 2 goes in, and it hits this arctan, right? We didn't have to simplify that at all because there was no sine or cosine in front of it. And then this root 2 also comes in, hits this root 2 up here, and that gives you a 2 times x minus 3 divided by, all right, now when we multiply these together, the root goes away. And heck, you know what? I'm just going to put it back to what the original denominator was, right? Just for fun. So we had x squared minus 6x plus 11. Of course, you could leave it as the square of x minus 3 and then plus 2. Okay, and so there we go. We finally got it. We had to put together a lot of tools to get there, but we were finally able to make this work. All right, if you have any questions, please let me know in the comments, and we'll see you. Have a great night.